Hi everyone. So in this video, I'm going to talk about condensing, expanding logs, and using change of base formula. So I'm going to try something a little bit different. I'm going to be using ActiveInspire to try to explain these three concepts. So let me know, email me, let me know how it goes. So again, like I said, we're going to do three things today. We're going to condense logarithmic expressions, expand them, and then finally use change of base. So the warm-up is right here, log base 2 of 4 plus log base 2 of 8 minus log base 2 of 16. Go ahead, pause the video, give it a try. Okay, so to simplify it, we know from previous lessons that log base 2 of 4 means what exponent do you raise 2 to get the argument of 4? Well, that's going to be 2. Log base 2 of 8, 3. And log base 2 of 16 will be 4. 2 plus 3 minus 4 is 5 minus 4, which is 1. You can also do it. You can also do this by a process that we're going to talk about today called condensing. So I'm going to hold off on that until we get to that point. Okay, so the three, this should be 4 log rules that we're going to be using today will be these 4 rows. So the sum product, if 2 terms have the same logarithmic base, base b, log base b of m, plus log base b of n is equal to log base b of m times n. There's also the difference quotient rule. So log base b of m minus log base b of n would be log base b of m divided by n. And then exponentiation, log base b of m to the c equals c times log base b of m. And then change of base, which is log base b of x equals log base a of x divided by log base a of b. So those are the rules that we're going to be exploring today. Okay, so taking that sum product rule, we're going to focus on this first. Okay, so I want you to keep that in mind, and we're going to talk about this on the next slide. Okay, so we're going to talk about sum product first. So these are just some examples. So condense a logarithmic expression. So the first one we're going to condense using the sum slash product law. So we have here log base a of x plus log base a of b. You see how they have the same base, a. Okay, so that means we can use this sum product rule. And because we have log base a of x plus log base a of b, we're going to rewrite it as log base a of x times b. So log base a of x times b. Okay. The second example, we have a subtraction expression. So let's go ahead and look at that difference quotient rule that we had. So I'm going to take a snapshot of that and move it onto this next page. So difference quotient says that when I subtract 2 logarithmic terms that have the same base, I can divide the arguments. So the way I would condense a difference expression would be to divide the quotient, to divide the arguments as long as we have the same base. So we're going to write it, for this example, we're going to write it as such. So we have log base a for both terms, log base a of x over b, and that's that. Okay. All right, for this one, log base a of x to the 4th plus log base a of b, we're going to condense it as that. So it's the same thing. So it's log base a of x to the 4th times b. And if we're condensing it, we can't really do much more without 4th in this example. But in the next example, we can. So log base 2 of x to the 4th plus log base 2 of b to the 4th. If we multiply that together, we have log base 2 of x to the 4th times b to the 4th, which is the same as log base 2 of xb to the 4th. And then I can use that exponentiation rule that we talked about with the last on the first slide. I can use that exponentiation rule that says that log base b of m to the c is equal to c times log base b of m. So I'm going to use that exponentiation rule here with this exact term, and I'm going to bring the 4 down as a coefficient because I can. So 4 log base 2 of x, it's not letting me write, of xb. Come back, where is it? Of xb, okay. Let's pause for a minute while I troubleshoot. Okay, it looks like my computer is cooperating with me again. So, so there we have it, 4 times log base 2 of xb. So that would be an appropriate condensation of the whole term, of the whole expression, okay? The next one has a different base. So natural log of 3 plus natural log of y, that's base e, right? So they have the same base, so I can condense them just like I did the very first one, except instead of log base a, it's going to be natural log, and then multiply 3 times y. The last one, log base 5 of a to the 4th plus log base 3 of b to the 4th, there's kind of a red flag here, which is that the bases aren't the same. So we cannot condense unless the bases are the same. So it's just a reminder to be vigilant about that, because they have different bases. We can't condense. It doesn't mean that there's not a number that this is going to be equal to. It just means that we can't use our sum product rule in this case because, or sum product law, because we have different bases. All right. So that's condensing. I want to move on now to expansion, which is basically the reverse process of condensing. So in math, we always talk about simplifying. We always talk about getting things down to a number or solving for x. So expanding, why would we ever want to expand a logarithm? And the reason for that is that in AP Calculus, if you take AP Calculus next year, you're going to be doing things called taking a derivative. And sometimes it'll be more convenient to do that work and other tasks, frankly, if you have simpler logarithmic expressions that are divided up instead of, or divided is a bad word, split up rather than a product or a quotient inside the logarithm argument. So basically, because this class is called pre-calculus, it's really about everything before calculus. So calculus is going to be where this will come in handy. Just being able to expand a log will make other processes easier. All right. So with expanding, we're going to use those same rules, sum and product, etc., except we're going to use them in reverse. So here's one example. So we have log base 2 of a times b over c. A times b means we can do log base 2 of a plus log base 2 of b, and then divided by c would mean that we would have to have log base 2 of c subtracted at the end of the expression. So we'll go ahead and write that out. Log base 2 of a plus log base 2 of b minus log base 2 of c. Example 2, very similar, and feel free to pause it and try on your own if you want before I go over it. So log base 2 of 3 plus log, it's like a 7, log base 2 of x minus log base 2 of 4, which honestly you could rewrite that as 2 because log base 2 of 4 is 2, but the objective is to learn how to expand, so we can just stick with that for now. And lastly, natural log of 4BD, we can split that up into ln of 4 plus ln of b plus ln of d. Okay, so these are in red, the examples that we just did. You can try these three on the right here, and I'll write the answers to them at the bottom, but you can go ahead and try these. So we've got log base 2 of D plus log base 2 of E minus log base 2 of F. 2 would be log base 2 of 4, which again is 2, plus log base 2 of C minus log base 2 of 5, and then 3 natural log of 3 plus natural log of C plus natural log of D. Okay, so that's condensing and expanding. Last, here are a couple of other examples that you can try if you'd like to on your own. One example that I want to point out to you is if you're asked to expand something like this, 4 times log of AB over D, remember that that is just like log of, because of the exponentiation rule, that third rule, that's basically log of AB over D to the 4th, which is basically log of A to the 4th times B to the 4th over D to the 4th, because you can distribute exponents. So you can write this out in expanded form as 4 log of A plus 4 log of B minus 4 log of D. So if you see examples like that, just know that it is possible to do it. It's just, that's how you kind of have to think about the whole expression. Okay, for this last part, change of base, this is the last part of the lesson. Evaluate each set of expressions, compare and contrast your answers. What do you notice? What do you wonder? Okay, so we've got log base 2 of 16 over log base 2 of 2, and then on the right we have log base 2 of 16. So go ahead and pause the video and answer these, and then we will go over them. Okay, so hopefully you noticed that the rows had the same answer. So this was 4 and 4, this was 2 and 2, this was 5 and 5. And this is kind of discovering a rule that is the case for any positive base, positive argument, which is that when you have log base anything of something else, you can rewrite it as a quotient with the argument in the numerator and the base in the denominator, as long as the new base you pick is positive. Okay, so this is actually the rule right here. This right here is the change of base rule. And you notice that we've got the original argument in the numerator, and we've got the base in the denominator, and then we pick a new base for the quotient, which is the same in the numerator and the denominator. Okay. So an example that we have here is log base 4 of 12, right? So you can write that as log of 12 over log of 4, right? Log with no base is just base 10, the common logarithm. You can write it as natural log of 12 over natural log of 4. You can write it as log base 2 of 12 over log base 2 of 4. Why do we do this? What is the point of it? So it is helpful if you don't have a fancy graphing calculator that will change the base for you. If you're working with a calculator on Google and you're trying to find log base 4 of 12, you can actually rewrite it, and I'll show you what I mean. I just Googled scientific calculator, and this is what I came up with. All right, so here's just a calculator from Google, okay? So I'm going to, I don't know what happened to the log function. I swear it was there. Oh, okay, here we go. Function, so we can do log of 12, and then we can close our parentheses over log of 4. So you can see that's 1.79248,125 and so on and so forth. Okay. But it'll also work if you do say natural log of 12 over natural log of 4. It's going to be the same thing. So log base 4 of 12 is log base anything of 12 divided by log base anything of 4. So the convenience of this really comes when you are looking at a calculator tool or whatever tool that you have. If you don't have the resources to be able to type this exact term in your calculator, you can find it using another base. Okay. So the last thing I want you to do today is find 4 different ways to use the change of base rule to rewrite log base 3 of 7. So I'll give you a minute to do that, or no, I won't. This is a video. Pause it and then resume it when you're ready. All right, so the 4 examples that I chose were natural log over natural log base 4.5 over log base 4.5, common log base 10 over common log base 10, and then log base 100 over log base 100. But just remember, just like we talked about, the argument has to go in the numerator and the base has to go in the denominator. Okay, so you can practice with that. You can test different examples of arguments and bases and see that they all come out to the same thing. Okay, so that was everything that we did in class on condense, expand, and using change of base. Hope this video was helpful. It was great to have you, and I hope you have a great day, and let me know as always if you have any questions. Bye.